Hello, students. Today we will study third chapter from 10th standard syllabus of NCERT. I am Professor Thomre. Explain this chapter to you, that is metals and non-metals. So we know elements in the periodic table, they are classified into two types, that is the left side portion of the periodic table are called as metals. They are electropositive elements, and the elements placed to the right side in the periodic table, they are called as non-metals. So broadly, elements in the periodic table, they are classified into metals and non-metals. First we will study metals. So we will study in this chapter physical properties, chemical properties of metals and non-metals. Now, the metals are the elements that conduct heat and electricity. They are malleable and ductile. Examples of the metals, common metals are iron, aluminium, silver, copper, gold, platinum, potassium, sodium, calcium. So these are different examples of metals. So metals are elements which form positive ions, means cations, by losing electrons. By loss of electron, that is called as oxidation. So metals are electropositive elements. Now we will study physical properties of metals. First property is hardness. So metals are, most of the metals, they are hard. There are some exception, alkali metals like sodium, potassium, lithium, they are very soft. They can be cut by using knife. So these are the examples of soft metals. Remember this, these are exceptions. Second property of metal is a strength. So most of the metals, they are strong, they have high tensile strength. Because of this, big structures can be made using metals such as copper, iron. Except this sodium, potassium metals, we can make these big structures, and therefore the metals have high tensile strength. Next property of metal is a state. So almost all metals, they are present in solid state at room temperature. There is a one exception, that is a mercury metal. It is present in liquid state at room temperature. Remember this exception. Then sound. Metal produce ringing sound. These metals are called as a sonorous. So which metals are the sonorous? The metals which produce ringing sound, they are called as a sonorous metal. The sound of metal is known as a metallic sound. This is cause that metal wires used in the making musical instruments. So this is the reason why metal wires are used in metal musical instruments, because metal produce ringing sound, that is called as a sonorous. Then next property of metal is a conduction. We know metals are good conductors of heat and electricity. This is the cause that electric wires are made up of metals of copper and aluminium. Next property of metal is malleability. Malleability means when metal is hammered, then by hammering on metallic part, that becomes converted into thin sheet. So this property is called as a malleability. This property is used in making big ships. So what is the use of malleability property in making big ships? So that is the important property of metal. Next important property of metal is the ductility. Ductility means when the stress is applied on metal part or the metallic piece, then a thin wire can be drawn. So this property is called as a ductility. So this property is used to make wires of metal. We know this copper and aluminum wires are used. Then melting point and boiling point. So we know we had studied this melting point. Melting point means it is a temperature at which solid state of substance is converted into liquid state at atmospheric pressure. Similarly, boiling point is a temperature at which the liquid state of substance is converted into vapor state at atmospheric pressure. Or the other definition of boiling point is it is the temperature at which vapor pressure of liquid is equal to atmospheric pressure. So that is called as a boiling point. But the meaning of melting is conversion of solid into liquid, and meaning of boiling point is conversion of liquid into vapor or gas state. So metals have high melting and boiling points. There are exceptions. The sodium and potassium metal, they have low melting and boiling points. Remember this exception again. Then next property of metal is a density. So most of the metals have high density. Metals or the solids have high density. Then color. Most of the metals are gray in color, but gold and copper, these are the exceptions. Next point from this chapter is to study chemical properties of metals. First important property of metal is reaction with oxygen. So most of the metals form their oxide when react with oxygen. The general equation can be given as metal plus oxygen give metal oxide. Here different examples are given. This is a potassium metal, that is a 4K, 4 atoms of potassium react with oxygen give 2 times K2O. This is a potassium oxide. Then similar reaction take place with sodium. Then next is a reaction with copper metal. Cu is a symbol of copper. When two atoms of copper react with oxygen molecule, it gives two molecules of copper oxide. Here 2 in bracket indicates the valency of copper. So that is the reaction of metal with oxygen. Now next is reaction of metal with water. When metal react with water gives metal hydroxide and hydrogen. So some examples are given here. It is sodium metal when react with water gives sodium hydroxide and hydrogen gas. So this is a metal hydroxide. Here it is a sodium hydroxide and hydrogen gas is given out. So this is one example of reaction of metal with water molecule. Then we know different metals. So this is the order of reactivity of different metals towards water. So most reactive metal with water is potassium, and the least reactive metal with water is Au. Au is a symbol for gold. So this is the reactivity order. Potassium is most reactive, then sodium, calcium, magnesium. Here it is As, that is arsenic, then silver, iron, lead, copper, silver, and the gold. So this is order of reactivity of different metals with water molecule. Then reaction with dilute acid. We know acids are dilute and concentrated. Here the example of dilute acid is taken. So metal react with dilute acid, give metal salt and hydrogen. Here is one example taken. This is sodium metal. Two atoms of sodium metal are taken. It react with HCl, that is hydrochloric acid, and give metal salt, that is a sodium chloride, and hydrogen gas. Like this reactivity order of metals with water, here the reactivity order of metals with dilute hydrochloric or sulfuric acid is given. It is potassium metal is more reactive like water, then sodium, then calcium, magnesium, like this. At the end here the mercury and the silver metals are given. So this is reactivity order of metals with hydrochloric acid and sulfuric acid, that is a dilute. Then metal oxides and their chemical properties. Metal oxides are basic in nature. Basic means it turns red litmus blue. Aqueous solution of metal oxide turns red litmus blue. So that indicates the basic nature of metal oxide. So reaction of metal oxide with water. Most of the metal oxides are insoluble in water, means they are not reactive. But alkali metal oxides are soluble in water, and alkali metal oxides give strong base when dissolved in water. Here the reaction of sodium oxide with water is given, that we will study. So sodium oxide react with water and gives sodium hydroxide. Then reactivity series of metals. Just now we had studied the reactivity order of metal. So this is, we had studied with H2O, that is the water molecule, and hydrochloric acid and the sulfuric acid. In general, this is given for all reagents. So order of intensity or the reactivity of metals is called as a reactivity series. So reactivity of elements decreasing on moving from top to bottom given in this reactivity series. In reactivity series, copper and gold and silver, they are at the bottom, means they are least reactive. These metals are called as a noble metals. So which metals are called as a noble metals? The metals having less reactivity are called as a noble metals. Examples are this gold and silver. Then potassium is at the top and hence it is the most reactive. So this is the order and this is given in the tabular form, that is a reactivity. First metal is the most reactive and the last metal in the series is least reactive. So that is about the order of reactivity of metals. After study of metals, we will study these non-metals. So non-metals, their physical properties, chemical properties, we will study their oxides, reaction with metal, ionic bond formation. So what is ionic bond? So ionic bond, non-metals are the elements do not conduct electricity and they are neither malleable nor ductile. The examples of non-metals are carbon, sulfur, phosphorus, silicon, hydrogen, oxygen, nitrogen, chlorine, bromine, argon, neon. These are the examples of non-metals. Now, non-metals are the elements which form the negative ions. Negative ion is called as an anion, and this is formed by gain of electron. Gain of electron is also called as addition of electron. Therefore, non-metals are electronegative. We had already studied that metals are electropositive. So the main difference between metals and non-metals is metals are electropositive and non-metals are electronegative. Now we will study physical properties of non-metals. We had already studied physical properties of metals. So these are exactly opposite for the non-metals. First is the hardness. Non-metals are not hard, they are generally soft. But here is the exception, diamond. Diamond is the naturally occurring hardest substance. So remember this well. This diamond, it is made up of carbon, and carbon is non-metal, and it is the hardest non-metal containing substance, that is a diamond. Then physical state of non-metals. Non-metals are maybe solid, liquid, or gas. Then luster. So non-metals have dull appearance, but here again there are some exceptions. One is a diamond and other is iodine. They crystals, they have luster, means shiny nature. Then sonority. We had already studied what is a sonorous property. So metals give ringing sound. This is called as a sonorous. Exactly opposite to this, non-metals, they are not sonorous. They do not produce typical sound on being hit. So this is sonority. Then conduction. So non-metals are bad conductors of heat and electricity. Here again, one exception, graphite. It is made up from carbon. It is allotrope of carbon. It is a good conductor of electricity. This is an exception. Remember this well. Next property is the malleability and ductility. These properties we had studied in metals. So non-metals are brittle. They are not malleable and ductile. Then melting point and boiling point. This property we had studied in metals. We know that metals have high melting and boiling point. We had studied exception also. Here, the property of non-metal. So non-metals are generally, they have low melting and boiling points. Next property of metal is a density. So most of the non-metals have low density. Then color. So non-metals, these are colored. This carbon is in the form of graphite non-metal which conduct electricity, and iodine is a non-metal. It is a lustrous having shining surface. Carbon forms diamond which is a non-metal which is extremely hard, and diamond is non-metal which has a very melting, high melting and the boiling point. So these are physical properties of non-metals. Now we will study chemical properties of non-metals. First is reaction of non-metal with oxygen. Here non-metal react with oxygen and give non-metallic oxide. Example is carbon react with oxygen, give carbon dioxide, and heat is produced during this reaction. Therefore, it is exothermic reaction. Non-metallic oxides, they are acidic in nature, meaning it's they turn blue litmus red. That is the acidic nature of non-metal. Now we will study formation of some molecules. Here, example of sodium chloride is taken. Sodium chloride, we know it is a common salt or also called as a table salt. So in this sodium chloride, sodium is metal, it is alkali metal, and the chlorine is non-metal. Atomic number of sodium is 11. So electron distribution, electron configuration, 11 electrons in sodium are distributed like this, 2, 8, 1, meaning it's, we know structure of atom. Atom consists of this central part positive. It consists of first shell, second and third, fourth like this. So first shell consists of 2 electron, second 8 and third one it is consists of one electron. So this is a distribution of electron in sodium atom. So number of electrons present in outer shell or outer orbit, it is a 1. Therefore, valency of sodium is 1. Valency means number of electrons present in outer orbit or outer shell. Second atom is chlorine. Its atomic number is 17. These 17 electrons in chlorine are distributed like this: 2, 8 and 7. Total 17 electrons. So electrons in outermost orbit are 8. So therefore valence electrons, these are not valence electrons, because here for the chlorine they require how many electrons to complete octet, that is called as a valency. Therefore valency of chlorine is also 1, but it is negative valency. For sodium it is a positive valency. Why it is negative and positive we will study. So sodium consists of one electron in the valence shell. It loses one electron and forms the positive ion, that is called as a cation. Chlorine consists of 7 electrons in outer orbit. To complete octet, it requires one electron. So one electron is taken from sodium. So it forms the negative ion, that is called as an anion. So sodium positive and chloride negative ion, they combine and forms the NaCl, that is the formation of sodium chloride. The next part of this chapter is to study this extraction of metal and how they occur in nature. So sources of metals are: metal occurs in earth crust and in seawater in the form of ore, and the minerals. Earth crust is the major source of metal. So what is the difference between mineral and ore? So this mineral are naturally occurring substances which have uniform composition, and the ore is a mineral from which the metal can be extracted profitably, that is called as a ore. So all ores are minerals, but all minerals are not ores, because these ores are the some minerals that contains the maximum percentage of metal. So metals found at the bottom of reactivity series, we had studied this. They are less reactive and they are occur in nature in the free state. For example, gold, silver and the copper. They are less reactive and they found in the free state in nature. But the silver and the copper, it combine with sulfur and oxygen and forms the sulfide and oxides. So these are the ores of gold, silver and copper. Now first step in the extraction of metal, that is a metal in the form of mineral and ore, can be converted into pure metal. So it involves, this process is called as a extraction of metals. So extraction involves, first step is called as a concentration. Concentration means the removal of impurities. We know when metal is obtained from this mines, it contains the impurities like soil, sand, stone and silicates. So this can be removed and this process is called as a concentration. So conversion, second step is a conversion of concentrated ore into crude metal. So roasting is one of the step in the concentration. So roasting means heating of sulfide ore in the presence of excess of air, so that sulfide ore is converted into oxide. So zinc sulfide, when heated, excess in air, that is 3O2 from the air, it react and give zinc oxide and sulfur dioxide. Parallel to roasting, there is a one process called as a calcination. It is also involved in the concentration step. So zinc carbonate is one of the ore. On heating, it is converted into zinc oxide and carbon dioxide. So in short, in the concentration, this roasting and calcination converts metal into corresponding oxides. Here zinc oxide and the zinc oxide. So this is a flow chart. It gives the idea for the extraction of metals. This is the outline for the extraction of metals. We know these metals have different reactivity. Depending upon that, the process of extraction of metal depends. So metal having high reactivity, medium reactivity and low reactivity. First, metals of high reactivity, they are obtained by electrolysis of molten ore and then converted into pure state. Then metals with medium reactivity, they occur in the form of carbonate ore or the sulfide ore. If carbonate ore, then calcination is carried out, which convert oxide of metal. Similarly, sulfide ore on roasting converted into metal oxide. Metal oxide on reduction gives metal in the crude form, that is impure form, and then it is purified, that is the last step called as a purification. It is also called as a refining. Then third type of metals, these are metals of low reactivity. They occur in the form of sulfide ore. Then roasting is carried out, converted into metal, that is a impure metal, and then refining is carried out. So third step involved in the extraction of metal is a reduction. So what is reduction? We had converted metal into metal oxide. This metal oxide from which oxygen can be removed, that is called as a reduction. So heating of oxide metal which turn into metal, so removal of oxygen is called as a reduction. Here we will study the difference between calcination and roasting. That is the second step carried out in the extraction of metal. We had already studied that this calcination is carried out for carbonate ore and roasting is carried out for sulfide ore. This is the main difference. Then carbonate ore is heated in the absence of air, and sulfide ore, it is heated with presence of air, presence of oxygen. Here carbon dioxide is released, and in roasting sulfur dioxide is released and we get metal. Here in roasting we get metal oxide. So calcination, one example is given, zinc carbonate. On heating it gives zinc oxide and carbon dioxide. Example of roasting, zinc sulfide when heated in the presence of oxygen gives zinc sulfide and sulfur dioxide. So these points differentiate two processes, calcination and roasting. Then electrolytic reduction. So how this electrolytic reduction is carried out? This is mainly used again for the removal of oxygen, and this metal is deposited on cathode. So electric current is passed through molten state of metal ore, and metal being positively charged, it is deposited at negatively charged cathode. For example, when electric current is passed through molten state of solution of sodium chloride, then sodium metal get deposited at cathode. Here the reduction of sodium ion take place, converted into sodium metal, and it is deposited at cathode. The reactions are Na plus electron give Na, and 2Cl minus electron gives chlorine gas. This chlorine gas is evolved at anode. So sodium chloride on ionization deposits sodium metal at cathode and chlorine gas is evolved at anode. The last step involved in the extraction of metal is the refining or purification of metals. When metal is extracted, it is not necessarily that it is in the pure state. Therefore, we have to purify this. It is called as a refining. Metal extracted from various methods contains impurities and it is purified by electrolytic refining. This is cathode, that is a negatively charged metal rod. This is anode, it is a positively charged metal rod. These rods are connected to the battery. This is acidified solution of metal salt. Here it is copper sulfate solution is taken. When electricity is passed, then reaction take place, that is reduction at cathode and oxidation at anode. So copper metal is deposited at cathode and here sulfur dioxide gas is given out at anode. So that is about the extraction of metal. Next point from this chapter is to study corrosion. So we had already studied this corrosion means the reaction of metal with atmospheric gases like oxygen, carbon dioxide, and this forms the metal oxide. This metal oxide layer that is deposited on metal surface, and this process is called as a corrosion. When corrosion of iron metal takes place, then it is called as a rusting. The rusting of iron is the most common form of corrosion. When iron articles like gate, grill, fencing, these are in contact with moisture and air, then upper layer of iron turn into iron oxide. It is a reddish brown in color. It is called as a rust. And this phenomenon is called as a rusting of iron. This rusting can be prevented. We had studied different ways of prevention of rusting. So this prevention can be done by painting, then by greasing, by galvanization. Galvanization means formation or deposition of zinc metal, thin layer of zinc metal on iron articles. That is called as a galvanization. Then electroplating and alloying, these are the different ways of preventing corrosion. The last part of this chapter is alloys. So what is alloy? It is a mixture of different metals, two or more metals or non-metals. They are combined, that forms the alloys. So different types of alloys are, it is a ferrous alloy containing iron and different other metals. Here the composition is given. Then non-ferrous alloys, they do not contain iron. For example, brass. It contains 80% copper and 20% zinc. Similarly, bronze. Then amalgams. What is amalgam? This mercury react with different metals and form alloys of mercury with other metals. These are called as amalgams. For example, sodium and mercury combined gives sodium amalgam. Zinc and mercury combined give zinc amalgam. Here are some examples of alloys with their composition. First is brass. It contains 80% copper and 20% zinc. So these are the different examples. You have to remember composition of these alloys, and that is about this chapter, this metals and non-metals. Thank you.